In the previous two videos, we have established that drift velocity is equal to E tau by m into electric field, and E tau by m is called mobility and electric field is V by L. So drift velocity can be written as E tau by m into electric field is potential difference applied across the conductor by length of the conductor. Here V is the potential difference across the conductor, this is not volume, and L is the length of the conductor. And also we have found that electric current is equal to N E A V D and current density J is equal to N E V D, and this is a scalar. Current is a scalar, current density is a vector. If you substitute the value of Vd over here, what you will get is J is equal to Ne Vd, E tau by m into V by L can be written as E, so this can be written as E. Now J is equal to N E square tau by m into E. This is called sigma or conductivity. So J is the current density, can be written as conductivity into electric field. Current density per unit electric field is defined as conductivity. As in the previous thing, we know that current is current density into area. Because NEAVD, what is missing here? A. When you multiply A here on both sides, that means current density into area becomes current. So the current is NEAVD. Vd can be E tau by m into E. So E tau by m means E and tau by m into A. This E can be written as what? V by L. So N E square tau by m, which we have already written as N E square tau by m is sigma. This can be sigma. So I is equal to sigma conductivity into A by L into V. The whole is a constant. Sigma into A by L is a constant, and this is called conductance. So conductance is conductivity into A by L. The reciprocal of the conductance is called resistance. Resistance is 1 by rho into L by A, the reciprocal. 1 by rho is called conductivity rho, and L by A, this is called resistance. If sigma A by L is conductance, reciprocal of the conductance is resistance. So I can be written as what? 1 by R into V, which implies that V is equal to IR. So the natural consequence of writing current I is equal to NEAVD, we are naturally coming to Ohm's law. V is equal to IR. R is the resistance. Resistance is the property of the material to oppose the flow of charges. Resistance is a property of the material to oppose the flow of charges through it, because there are a number of collisions are taking place, and the sum total of that opposition of the conductor to resist the current is called resistance. So the more is the potential difference applied, the more is the current. So I is directly proportional to V, and V is equal to IR. Then if you draw for any conductor V versus I, V is the independent variable, I is the dependent variable. The more is the V, the more is the I. If VI graph is a straight line, such kind of conductors obeys Ohm's law. That's why those conductors are called ohmic conductors. Ohmic conductors. And if it does not obey Ohm's law, if V versus I graph is not a straight line but something else, then those materials, those conductors are called non-ohmic conductors. So V is equal to IR is Ohm's law, and materials that obey Ohm's law, that means their VI graph is a straight line and they are ohmic conductors. If they are not a straight line, then if the VI graph is not a straight line, those conductors are called non-ohmic conductors. The next session we will talk more about resistance. Rho is equal to resistance R is equal to rho into L by A.